Our next speaker is Isaiah Swan. He was working in the Weinschenker lab this summer here at Emory, and his daily mentor was Carl Schmidt, and he'll be joining us to talk about alpha-1 adrenergic receptor antagonist effects on cocaine-seeking behavior in rats.
Hello, so my name is Isaiah Swan, and more broadly I'm going to be discussing the effects of, or the role of norepinephrine in cocaine addiction. So first of all, for a few statistics, cocaine, or substance abuse in general, costs the United States alone over $550 billion annually for healthcare costs, crime prevention, and things of the sort. And more specifically, we can see that cocaine abuse itself has pretty large, it's a prevalent problem in the United States alone, because in the United States alone, from 1999 to 2008, there were over 75,000 deaths related to cocaine overdose. So first of all, I'm going to discuss the neurobiology of cocaine. So this is normally what would happen in a dopamine pathway. So first of all, we have a presynaptic neuron right here, which is the sending neuron. And what it will do is it will manufacture these dopamine molecules, which it will then send to the postsynaptic neuron. And this is like the receiving. So these dopamine molecules will bind to dopamine receptors on the postsynaptic neuron, which will then cause a action potential to occur, and so on and so forth. And that is how we have those pleasurable feelings that are associated with dopamine. So once those, just going back a little bit, once those dopamine molecules bind to these receptors, they will come back off of the receptors into this gap here, this synaptic cleft, and it will be reuptaken by dopamine reuptake transporters, and then they will be broken down. However, with cocaine acts as a reuptake inhibitor, and therefore it will block those dopamine reuptake transporters, and dopamine molecules will stay in this synaptic cleft and continually bind to these dopamine receptors, which is why drugs such as cocaine and other stimulants are so addicting and effective. So this is a little bit about the drug addiction pathway. We have these three regions, which are the big three that are associated with drug addiction. And we know that dopamine, which is a neurotransmitter, which is like the chemical signal for everything, we know that dopamine is produced in the VTA, and the VTA will project or send connections to the nucleus accumbens and prefrontal cortex, and it will send dopamine to these regions. And we also know, so this is why cocaine abuse is so damaging and so effective, because it messes up this entire dopamine system. We also know that the noradrenergic pathway, norepinephrine is another neurotransmitter, which is typically associated with stress and things of the sort. We know that this pathway also innervates the drug addiction pathway. It innervates each region. And this is important because all medications and test drugs that have been applied to dopamine and have been targeted at dopamine have all failed. So we are looking for different directions to take treatment in, and which is why we're looking at norepinephrine here. So, as I said, norepinephrine is a neurotransmitter, and it has 9 different receptors, I believe. However, we're only going to be looking at this one receptor because norepinephrine and this one receptor have been implicated in drug-seeking behaviors. So a study in 2005 done by Zhang and Costin proved that when a drug named prazosin, which is an alpha-1 adrenergic receptor or A1AR blocker, when that drug is administered to intraperitoneally, that is administered to the entire body and the entire brain, we see that drug-seeking behavior is reduced. However, we don't know where this occurs exactly in the brain and along this pathway. So our question is, where does it happen? And we believe that it occurs, that the A1ARs in the ventral tegmental area, as aforementioned in the previous slides, we believe that those A1ARs are going to be important in playing a role in cocaine crime reinstatement, which is the relapse basically. And therefore, by blocking those receptors in BVCA, we would expect for there to be a reduction in drug-seeking behavior. So what we did was we took 7 male Sprague-Dawley rats and we catheterized them, meaning that we stuck a tube down through their back and over into their jugular vein so that they would be able to self-administer cocaine by pressing a lever. Next, we cannulated them, so we inserted 2 cannula. I'll show you that in a second. We inserted 2 cannula into their brains, which allowed us to target specifically the ventral tegmental area for infusing drugs. So this is a figure showing how exactly self-administration works. So a rat will press a lever, which will go to a programming box, which will then go to an infusion pump, which will then infuse the drug directly into the rat. So these are the 2 cannula. We see that in this chamber that there are 2 levers. There's an active lever and an inactive lever. An active lever press resulted in an administration of cocaine, whereas an inactive lever press was not punished. And these are the 2 cannula, like I said, which were used for infusing the drug, which I will get to in a second. So the rats were placed into the chamber for 2 hours, where they would be where they would go through a 2-hour self-administration session, meaning that they would be placed in there and be able to press the levers as many times as they want, do whatever they want while they're in that box for 2 hours, and then they would be taken out. There were 2 groups. We had our control group and the experimental group. The experimental group would receive an infusion of terracicin, which is another alpha-1 AR blocker. They would receive an infusion of that drug directly into their cannula, which went to their VTA. And then they would receive an injection of cocaine before being placed into the box and going through a session. The control group, on the other hand, received an injection of artificial cerebrospinal fluid, which is basically similar to a saline solution, in that it doesn't really do anything to the rat. And then they would be injected with cocaine and then placed into a self-administration session. So what we see here is that the active lever presses, which would normally administer cocaine, didn't really change much between both of the groups. There was no significant difference at all between them. So therefore, we must conclude that the alpha-1 ARs in the ventral tegmental area are not important at all in cocaine crime reinstatement. Now, we did have some limitations. First of all, the dosage that we used was based off of prior literature. However, there was no dosage curve or dose curve really constructed for this, so it is entirely possible that a different dosage could have another effect. And we also only did one injection before placing them into the chamber, so that could definitely have an effect. Now, some future directions that we could take this in we've already started pursuing those. So we have began testing the nucleus accumbens and prefrontal cortex and we have some pretty convincing evidence that is leading us to believe that by blocking those A1ARs in the prefrontal cortex, we would be able to attenuate or reduce those drug-seeking behaviors. So with that, I would like to thank the ION program as well as my fellow peers and teachers. I would also like to thank the Weinschenker Lab as well as my mentor Carl over here. And I would like to thank the funding agencies.